Hello, welcome to Nuggets for Life. My name is Peter Müller and I have created this video series to share with you some ideas and concepts that can change your life. Let's get on with it. Hello, welcome to Nugget number 14, Supplements and Bodyweight Part 3. Today we talk about proteins. The photo on the left hand side shows me at the state championship in bodybuilding of North Carolina, and this is to show you whatever I tell you about protein and nutrition I have used to achieve this kind of physique. Now, what happens when we eat and drink our calories? There are few key things happening. First of all, everything what's happening in our body is an energy conversion. We bring in our food stored chemical energy, which then, as you can see, can be used in three different ways. First, it goes to the base metabolism, which is in essence to keep us alive. Breathing, digestion, blood pressure, heart rate, and our thinking, last but not least. Our brain uses about 20% of the energy of the basal metabolism. Then we have our day-to-day activities, whether we are a construction worker with heavy physical exercise or if we are a secretary in the office working on the computer. And if we put more energy in our body than what we use, then our body stores the energy as chemical energy, either as glycogen, which is our carbohydrate storage, or as body fat. And these are the two places. And remember, proteins cannot be stored in our body, but we live in a permanent renewal process of our proteins in our body. So this video segment is basically talking about how to make sure we get the proper quantity and quality of protein into our body. In the nutrition, we know it. The classical ones which high protein contents are meat, fish, poultry, milk, dairy products, and last but not least, bodybuilders and elderly people. To make sure that they get proper protein, they use some protein supplements to make sure they get the right amino acids into their body. Now, I mentioned the word amino acids because what are proteins? Proteins are long chains of amino acids. And there are 20 amino acids, and I will explain a little bit later what they are in detail. But just is to give you a little understanding, on the top left corner, the basic form of an amino acid is, when you look at the above right corner of the chart, it is this chemical group COOH and then NH2 on the left hand side and H on the right hand side. This is the basic form of an alpha amino acid, and below the red line these are the different formations which constitute the different amino acids. Now, these amino acids, they are connecting to each other and they form long strings of it. And if a string is, let's say, between 10 and about 50, it's called a peptide. And if it is between 50 and 1,000, they are called proteins. And those chains of amino acids, which look like strings, they are three-dimensionally put together into a three-dimensional configuration of a protein. Now, we know protein basically only as muscle protein, we relate to it. But in our body, I've just listed a few key proteins and peptides. We have literally thousands of different proteins and peptides in our body, which have highly specific functions in our body. As the peptides, you all heard about the hormone insulin and glucagon. These are two peptides which are necessary to regulate our blood sugar. Then you know EPO and human growth hormone. two substances well known in the doping world. Lance Armstrong was doping with EPO to win the Tour de France 7 times. It is a peptide which regulates the capacity of the blood to load with oxygen. Then we have other ones. Ghrelin and leptin are two hormones which are relating to our appetite stimulation and suppression in our body. Then on the right hand side, on the proteins, you know collagen, creatine and elastin. Elastin, a very important protein. It is 1/3 of our skin is made out of elastin, which is the protein which keeps our skin elastic. And the older we get some wrinkles because we produce less elastin, and that's how the skin quality goes down by age for most of the people. Then we have hemoglobin and albumin. We know the key proteins in our blood to transport oxygen and to keep our antibodies alive. Our whole immune system is based on it. Insulin, glucagon, again, regulating our blood sugar content. And last but not least, the antibodies and interferons, which deal with our ability of the body to fight bacteria and virus. Now, at the core of every protein and peptide, there are these amino acids. And we have 20 different ones in our body, and they are divided into two groups: essential amino acids and non-essential amino acids. The non-essential amino acids are those amino acids our body can produce on its own. So from our nutrition, our body has an internal machinery being able to produce these amino acids. You see alanine, arginine, asparagine, aspartic acid, cysteine, glutamine, and so forth. On the left-hand side, you see the essential amino acids. These are the amino acids the body cannot produce. We have to bring them to our body as a base material, as building blocks to build the proteins and peptides. And there are the very important ones, the so-called BCAAs, the branched chain amino acids. These are the amino acids where we use a lot of them, which are used in the construction of our muscle fiber. And then we have other essential amino acids, threonine, methionine, histidine, and tryptophan, and so forth. We have to get them through fruits, vegetables, and with our animal protein to us, because the overall process is always the same. We are getting proteins and peptides into our body. In the stomach, we hit it with hydrochloric acid, basically. We destroy the proteins and break them down into peptides and individual amino acids, and the body then absorbs in the intestine the amino acids, brings them into the blood and distributes them to the cells in the body, and then in the periphery, they are reconstitute, rebuild proteins and peptides. So in our nutrition, it is important that we add essential amino acids to our body because they are later needed and essential to build our proteins. Now, you know there are so-called different quality proteins. It has to do with the fact how the amino acid mixture, the composition is, so the amino acid profile, and secondly, whether our body can really break it down and absorb the amino acids then into our body. I've given you an example, keratin, which is in our fingernails, for example, and in our hair. They have a lot of protein in it, but if you try to eat your fingernails and expect to be rebuilt as body muscle, it doesn't work. Our body cannot break down fingernails. But when you drink a glass of milk, the milk protein, when it comes to the stomach, can be easily broken down into amino acids, and they can flow in the body to be rebuilt. Now, in order to determine the quality of amino acids, there are many methods to measure it. Here are the two most frequently used ones. The so-called biologic value, which essentially looks at the amino acid profile. So the composition, which amino acids in which quantity, how they are and how closely they get to the profile we have in our human body. So the biologic value of 100, which was originally the standard, was designed with albumin, with a pure egg white, and this was the standard. So the amino acid mixture of the egg yolk plus the egg white, the full egg, has a biologic value of 100, and everything which is below the mixture of the amino acids, it's not so perfect. You know, for example, when you eat flour, when you eat rice, when you eat corn, they have a lower biologic value. They have a lot of protein in it, but the body cannot perfectly use it. It's kind of like you go to the gas station and you get a low octane fuel into your car. It doesn't run as good as if you have the high octane ones. Then we have the DIAAS score, the digestible, indigestible amino acid score, which essentially says what percentage of the protein you put in, the body can actually, first of all, break down, and secondly, absorb into the body and use it to build the own proteins and peptides for the body. And here I have a protein hit list, and this is for people when you actually look to get high concentrated, high value protein nutrition. You go to this list you see on the left hand side. I have the food item, and then in the vertical columns you have various criteria. You have biologic value, you have DIAAS, you have the calories coming from protein, and the percent of protein of total calories in the yellow column. And I've sorted them. This essentially says the highest concentrated nutrition, where the percentage from calories comes from protein, are on the very top of that list. So bodybuilders, they look always at this list and look, if they want to get high protein, they go to this hit list. It starts with cod, fish and meats and dairy products. They are always on the top list of bodybuilders and for people who want to have high quality, highly concentrated protein. So you have cod, shrimp, egg white, turkey breast, Greek yogurt, often underestimated, chicken breast, lean pork, lean beef, and so forth. And you have also soybean, flour, and so forth. But when you go to these, you always have to look. You have on the one hand high concentration of protein, but when you look at biologic value, the mixture might not be as perfect. And when you look at the digestible, indigestible coefficient, then you see they are at 70-60, meaning only 70% of the protein you actually take into the body can be used by the body to go to the outside. And here I continued my protein hit list. By the way, if you want this list and if you want the detailed list from the FDA, which has 7,000 food items in the United States, listed in this kind of form in an Excel spreadsheet, send me an email and I send you this list. You find any food item you can think of, giving you all these kind of detailed information as a basis if you want to build a nutrition plan for yourself. Last but not least, here is the kicker. I gave you a list here of power combinations of products, food items, which on their own don't have necessarily a biologic value of 70 or 80. But when you combine two of low value ones and you combine the right ones, you can increase the value of that substance. For example, bean and corn mixed at 1:1 create a biologic value of 101. It's basically the quality of beef or an egg white. But beans on their own have a low one, and corn on its own has a low biologic value. But combining them, that's perfect. Potato and soy, potato and egg, soy and wheat, whey protein plus potato, and beans and corn. These are favorite mixtures to get a biologic value of above 100, which is a very high quality protein. This is it about proteins and peptides. I hope it gave you enough detail to create your own nutritional plan and selecting the right food items to increase the protein quality and density of your food. Thank you and see you at nugget number 15.